Okay, so today I'm going to work through the example, determine the minimum distance from the point 4, 2 to the curve y squared equals 8x. So as soon as I see the word minimum, I know I'm going to have to do the first derivative of an equation that represents the distance. So as with every other example we've done, we want to create a sketch. So this graph is going to be y squared equals 8x. So it's not a traditional parabola. It's a sideways parabola because the y is squared this time and not the x. So I'm just quickly going to sketch an xy plane. And I know that I'm going to have a vertex at 0, 0. So I'm going to do my best to draw a parabola. All right, not too bad. And then it's asking for the point 4, 2. So point 4, 2 would be somewhere around here. And again, it's just a sketch. It's asking to find the distance, the minimum distance to a point on the curve. So I'm arbitrarily going to put this point right here. And I'm going to say that this represents my minimum distance. I don't know where this point is. So I'm going to call it point P and give it the coordinate xy. I have 2 points. We learned in grade 10 that the distance formula is going to equal the square root of 4 minus x squared plus 2 minus y squared. So really we're just doing the Pythagorean theorem where we're looking at our rise and our run. But again, like everything else, we have 2 variables. So I'm going to isolate my equation for x. So I have y squared over 8 equals x. Could I take the square root of 8x and use that instead? Yes, definitely. However, if we can avoid using roots, it makes the math a lot easier. So I'm going to replace my x with y squared over 8 plus 2 minus 1 all squared. And then I'm going to use the power of 1/2 because it makes taking the derivative a little bit easier. All right, so now that I have my expression, I'm going to take the derivative of the distance equation with respect to y because that's the variable that I have. I have 1 over. I'm going to rewrite my expression in the denominator because when I take the derivative, oops, I forgot to square it here. So I should have a squared here. I end up with a negative exponent, which goes to the denominator. So now I'm going to use my chain rule and take the derivative of the inside. So I have a 2, 4 minus y squared over 8, multiplied by the inside, which is minus 2y over 8. Moving on to the second term, so 2 multiplied by 2 minus y, multiplied by minus 1. So now I'm going to simplify this. So when I expand through the bracket, I am going to end up with, so I have 2 multiplied by 4, which is also multiplied by negative 2y over 8. So that is going to give me negative 16y over 8. Then I'm going to have plus 4y cubed over 64. I'm going to reduce this stuff afterwards. Then I'm going to have minus 4, and I'm going to have plus 2y. Negative 16 divided by 2 is negative 2y plus 4y cubed minus 4 plus 2y. So the 2y's become 0. I'm going to move, first I'm going to put my 64 in. I'm going to put that negative 4 to the other side. So then I have 4y cubed over 64. 256 equals 4y cubed. 64 equals y cubed, which means when I do the cube root, I'm going to get 4 is equal to y. Now in our expression, we learned that x was equal to y squared divided by 8. So x is going to equal 16 over 8, which is 2. So now I'm going to go back and read the question to see if I've actually answered it. So it said, determine the minimum distance from the point 4, 2. So I am being asked to actually find the distance. So I know that S is equal to the square root. I determined that X has a value of 2. So I have 4 minus 2 squared plus we found Y was 4, 2 minus 4 squared. So 4 subtract 2 is 2, I square that, I get 4. So I have the square root of 4 plus 4. So S is going to be the square root of 8. So the minimum distance is going to be 2 root 2 units. So that's how you can find the minimum distance. The key to this question is recognizing that the equation is something that you can rearrange and sub into the equation to minimize the number of variables that you have.